Hello, good day to everyone. Welcome to another episode on mold flows, tips, and workflow. Now, those who have already seen my earlier clip on exporting the warp model, this is and one step ahead of that episode. I came up this episode particularly to clarify some of the doubts related to the export of warp geometry and get a clarity on probably you already been trying out the export to the opposite warp geometry that's everybody is aware of, but there was some questions around it. What would be a scenario if you export a scale model? What would be a scenario if you export in a compensated model? So let's get a clarity on that. As you can see on my screen, I started with a basic geometry. Uh, a CAD model is must. A solid CAD model is must if you want uh, to have this workflow. I put up the two simple uh, gate locations with only like a no feed system attached, and then rest of the process parameter settings and meshing and so on and so forth. So let's get started with it. I completed the basic warpage model, warpage analysis, that is fill, pack, and warp, and I could able to see deflection of around like 1.4 uh, on the scale. Let's try and export these model as in CAD and actual one. Okay, and while exporting, make sure that you are keeping these as an actual export model. Again, to export this model, you need to have an CAD geometry, a solid CAD geometry. A IGS file or a surface data will not work. Neither the STL file, if you're trying to import and then meshing, it won't work in this case. And then export it, and it gives a that you are exporting. This is a notice. It gives that it need a clean CAD geometry, and then it goes and puts to the locations. I already exported the actual warp just to save the time. And then in second case, what I'm going to do is I'm going to export now, but with the warp geometry in actual with an percentage of shrinkage percentage. I'm going to add a shrinkage percentage of 0.4%. That comes out to be scaled out to be like in 1.04. Okay, and keep it on the CAD, and then again you export it. Again you get it the same notice, and I have exported these as a scale 1.04. Okay, and then the simplest form is like to export it is in the warp opposite, which everybody does it at. So I also did it in an export into the warp, and make sure that you put it on a CAD. Never do it in STL or so. The reason why, I'll let you know in another minute time. And then I exported the actual opposite warp SAT file. You can export it as a step file as well. And and then many people they ask me like, what would be a scenario if you put go into the deflection plot properties, and then instead of put in compensation of isometric like zero point 0.4, the same way I did it with the scaling. Apply it, and you can see that my scale has been reduced to 1.3 from 1.7. Okay, and then I'm going to export these warp shape actual, because now I compensated it CAD, and I'm put these as a compensated, and you can see that I have already exported the compensated with zero point 0.4 as well. So in all, I have four warp models: opposite and actual, some scale with compensated. Now what I'm going to do is I'm going to compare all of these with my actual CAD geometry. how they are close to my actual CAD geometry after it. Of course, the warp model won't be compared, but I want to see that scale model, the compensated model, and the opposite model, how they are, comparable with my CAD geometry. Now, the the members which are already in active subscription should have access to the Fusion 360, and you can open all of these models in the Fusion 360. So I recommend it. If you're not installed, go ahead and install it. You can use it in a much better, effective way. Need not to depend upon any of the third-party CAD solutions to do these comparisons. I have a CAD geometry which is the original one, and there's absolutely no warpage. Everything is perfectly fine, and this is where we want to achieve it. Now, the easiest one was to export was the opposite of it. And before I go on to the opposite, let's go and do the actual comparison, actual CAD model comparison. So I on it, and I can see that now the my yellow CAD is of the actual warp geometry, and I could see a difference between the CAD and the warp shape. Of course, this is what we would able to see into the into Morphflow as well. If I remove the compensation and apply it, and I could able to see that, hey, this is what it is looks like to be that, like the gray one is the CAD, and the reflected one is the warp geometry. The same way I could able to see over here as well. And then what we did is we exported the opposite shape. Of course, the opposite shape would be completely the reverse of the actual warp. So yellow one is the actual warp. The middle one is the CAD geometry, and then the reverse warp. So you could able to see. Now always the confusion lies between the scaled model and the compensated model. Let's compare now the actual CAD model with the scale geometry. Now I exported, and this is the scaled one. Of course, the scaled one, it will be having the warp, but it is expanded, means it applied the compensation. It's very similar way, the way we apply the compensation actually. It is just like adding a shrinkage to it. Now, does the compensated model and the scale model are same? Let's go and see the comparison. So now I on this actual warp model, okay, with the compensation of zero point 0.4, and then when I'm comparing it, it's absolutely matching to the CAD, okay, over here, and but it's not uh, matching to the scaled one. Actually, there is a difference between the, so the, though we see that it's the same scale, no, I think there's a difference between the scaled shape and the compensated geometry. And which one is looks to be closer? I find that the compensated geometry, it looks much closer, but it depends upon like how you're comparing, whether you're comparing with the, you know with what coordinate system, or I just superimposed, and I use the same coordinate system and didn't change anything. It just gone and sat over there. Um, so probably, I need to little bit change it. If I move the gray one, you can see that the green one uh, and the yellow one, if I try to match the coordinates, probably I would be able to get a very similar to. So I personally, I don't see a between the difference between the the compensated one and the scale one at this point. But if if this would have been in a centroid or the same, then I would say that the compensated geometry is much closer to the actual part actually, which will be getting out of the mold. So I leave it to you to take the call because it's very critical, because anything that you make the changes into the mold, it's going to last. A minor changes here or there could miss your critical dimensions. The purpose of this episode was to get the clarity between the warp geometry, the actual geometry, and the original geometry, and compensated one and the scaled one. So you can superimpose all of these, and many people, they want to do the superimpose and check the how they are closer to the actual CAD model. I hope this exercise would help, you know, in discussion with the tool room team, and get closer to the actual CAD geometry. With that, thank you for your time, and we'll talk to you again. Thank you.